Hello, everybody. Welcome to this kind of impromptu stream. A lot of things kind of fell through this week, so yeah, no video for this week. But as mentioned, we're going to sit down together and build an ant weight on stream. I've got 3D design set up with most of the things I think I need today. What I kind of want to do with this is build a lone robot. So we're not building anything really high-powered or spinnery. I want something kind of easy to drive, simple to build. Yeah, just a lone robot that we can put into the arena because ARC should be coming back fairly soon, and I would actually like to put some lone robots in to the arena when we get there. So I already have stuff like a very old design of mine, which is the mini model, which is a ant weight version of my very, very old 13 kilo robot. Hey, Razor in chat. And, oh, you're listening to Give by Silent Partner. Awesome. Yeah, I didn't know that you could find that stuff outside of the YouTube music library, which is where I get all of that stuff to put into videos. Yeah, so like I said, we're going to be doing lone robots and hopefully something a little bit like this, but maybe not quite so much. What I wanted to do was I've been a little bit inspired by magic cards recently, so I wanted to build something based on some geometry seen in some magic cards, which is a bit of a weird thing to say, but let's have a look here and I'll kind of show you what I'm talking about. So like this is the first magic card, and just this like kind of headpiece up here I think would make a really interesting scoop. Maybe cutting off these top sections and just making this like a down scoop into kind of like a V shape I think would be really cool. It'd definitely be a more interesting wedge than what I've built in the past. And I've got a bunch of different ones here. So this one I've kind of got, there's a couple of different inspirations. You could take like a conical wedge off the hat here, or the top of the archway kind of gave me an idea to have like a pointed middle and then scoops on the edge to kind of make a weird dustpan that doesn't have a bottom, which I don't know, I kind of like that idea, which is again why it's here. This one, I literally just for the face, I really like the idea of like a little crab. So I'm thinking like the claws off of Slammo on the side of the head as a kind of, yeah, grabber robot. It's only really going to have two wedgelets, kind of one either side to make up the little grabbers. But I think, yeah, a little like crab robot would be kind of cool. And hello, Henry, in chat as well. And finally in here, I've got this, which is a little bit hard to see. Let's zoom in on this guy. This mask shape is just interesting and kind of makes a like very narrow scoop kind of thing, which I think could be quite cool to do as a robot design. And you could also like kind of add elements of this interesting mask into the actual lid of the robot, which I think is pretty cool. How's the search going for ARC's new venue? I think pretty good from what I've been told. I obviously don't run ARC, so I'm not fully in on all of the details on everything that's happening with them. But it's looking like we should have an event sometime at the end of next month, which I'm taking that to mean that looking for a venue and kind of searching all that stuff through is going pretty well. But nothing is like fully set in stone yet. It's just kind of the talk that is happening right now. Yeah, so does anybody have any preferences on which way we go here? One being the big white and blue here, two being our little alleyway friend, three being our little spider bug thing, and four being this ninja in here. I don't think personally I'm going maybe one or two, although I'm not 100% sure that I can design two in 3D design. This is a very complex organic shape, and 3D design is not really set up for complex organic shapes. We could definitely try, but we won't get quite this level, I don't think. As much as I do like this face shield, I think that this little scoop is a little bit too shallow, like there's not enough grab in it to be a useful scoop. Which kind of means it's just a bit of a rambot, and yeah, rambots can work, but a wedge is going to beat a rambot like 90% of the time, because you just get in underneath and they, get more stuff on. All right, so we've got one vote for the archway and one vote for the first idea. I think as I'm kind of leaning that way as well, I think we'll start on the first idea and see how far that gets us. And then if we kind of stall out here, then we'll move on and maybe try something out of the archway instead. So this guy is a bit of an interesting shape, but that's like exactly why I wanted to do this. So it kind of scoops out this way. Whoop, where's my... There we go. Yeah, scoops out this way and then folds down forwards, which is going to be complicated to do because there's kind of a double angle on this, which is interesting. So we're going to give that a shot anyway. I think I bought in the old triple point chassis to maybe start work off of there. And you know what? We almost could, actually. We could use this front face to give us that first angle, I think. So I'm thinking these front two faces could give us this angle in here. We might need to steepen it out just a little bit, but I think that could actually do pretty well. The thing is, we were going to have to cut the points off of this robot anyway. Because, of course, those aren't going to survive on the main model. So let's just do that really quick. 123D is kind of good for this. It's fairly easy to just like cut a model in multiple pieces, as long as you don't cut off anything you actually want on the model. So that should get rid of that stuff. Do that all over again. And split. Come on, give me the face, not the whole thing. There we go. Have to get into some weird spaces to do this. There we go. And then cut off this as well. All right, so that is now the whole robot without those faces, which I think is a good start. Might even bring that back wall in a little bit, just so that the angle is not as steep and it's not as kind of, yeah, it doesn't give it as much of a butt, I guess. That's interesting. Those should not be there. Okay. I'm going to have to cut those off in half a second. Actually, we'll just do that now, because this should do the same trick and work exactly the same as it did before. Okay. That's fun. It's one of the only problems with 123D Design is every now and again it kind of freaks out a little bit with all the cuts and operations and decides that a thing that you want to do, you cannot do. There's always ways around it, though. Okay. That's, interesting. Alright, I think we're going to leave those for now because worst case scenario, we'll cut them off in, like, Tinkercad or something, which shouldn't be too hard to do. But also, they are wafer thin, which means that a 3D printer shouldn't pick those up anyway. As long as the whole STL exports correctly, it should be fine still. Alright, so we're going to start work on these scoops. Now, we've got this nice paneled section out the front here, but we need it to angle in a little bit. If we go off of our model, you can see that like there's an angle here. The angle is the same way that a wedge normally would on a combat robot. So we definitely want to get that in. We might also... I might be pushing my luck trying to split this part more, but we might also just give us a little bit of extra width here, I think. Let's see what we can do. Split that by that. Cool. Seemed to work okay. Let's see if it actually survives. How much more do I want to go? I think 6 is probably enough. It's a decently sized robot as it is. So, yeah, there we go. Cool. And then we just need to push these parts back together. Yeah, that's interesting. That's okay. We can fix that, no problems. So rather than doing it that way, we're just going to mirror the parts because, well, mirror the one plane that worked. And not worry about it. Okay, this is deciding to be very annoying today, apparently. We might have to, like, cut that whole back wall off and rebuild it. That might be the best way to go, I think. This 123D is really freaking out about this back wall at the moment. Let's give that a shot and see if it works. Okay. Or we just leave it as is. I think we might leave it as is. How would a vertical reverse spinning disc work? And you use it like a cutter. So here's the thing about any design that requires cutting into the opponent is that you don't really think about it when you're using like a grinder or a hacksaw or a bandsaw or anything, but you are putting significant force into the part to get the blade to bite in and cut the piece that you're trying to cut. So you don't get that in combat robots. Unless you are jamming somebody up against the wall, you don't have good pushback from them. So your cutting blades aren't going to cut. They're going to nibble tiny little pieces off. You're going to get one or two tooth bites into your opponent every single time you engage, which means that you're like taking tiny little chips off your opponent. What you need for a cutter to work is prolonged contact with a decent amount of force behind you, which is just not something that you can do in a combat robot. With the minor caveat of overhead saws, because in an overhead saw, you trap the robot in underneath the saw and pull the saw down into them where there's nowhere else for them to go, and then you can get the cut in. But if you're just going to mount a saw blade to the front of your robot, it's going to act more like a vert as a spinner than it is going to act like a cutter, just because that's how the physics of that plays out, essentially. And because of bite, you're much, much better to just have a bar with a single tooth, or, you know, a bar with two teeth, or a disc with two teeth. Because, yeah, you get more bite when you've got less teeth, which means you can transfer more energy and deal more damage at the same time. I hope that helps. Yeah, cutters just aren't particularly a good idea in combat robots, unless, of course, as mentioned, you are doing a saw blade of some description, and an overhead saw blade specifically. I mean, I did try at one point to do a hug saw, like where two saw blades came in together and trapped the opponent, and I still think there's merit in that. I just think it's way too heavy to be done in an ant weight. Like, the two arms both need motors and both need saw blades, and there's a lot going on there. I think the first weight class that would work would probably be like featherweights, I would say. It just, yeah, there's too much going on there for it to be in like an ant weight or a beetle weight, because you just run out of weight way too quickly. So let's get some wedges going. 28 by 42.8. Interesting. Okay. 28 by 43. We're going to call that. And width, we want 2. So that should merge into there quite nicely, but now we want that to wedge out. I think we want like a 45-ish. So the easiest way to do this, I think, is going to be to put that on there and then smart rotate. Grab that. And if we like... Oh, we don't want 45, because that's like... 45 is going to be huge for this particular design. 30 would be pretty good, though. Something like that, I reckon. Regarding the latest BattleBots application, where did the name Zap come from? I mean, I've had a bit of an electrical theme with all of the designs that I've applied for BattleBots with, other than MacGuffin, although MacGuffin should have had more like electricity in the logo. We probably would have got there eventually, but just hadn't quite. And I kind of wanted to keep that a little bit. I do like the electricity theme for the team because we are like Team Bolt as applying for BattleBots. I'm not applying as Team Panic, I'm applying as Team Bolt because Team Bolt is me plus members of ARC, so it's not just Team Panic, it's all of us combined, and we all have our own teams, so rather than applying under one of our team names, we apply under Team Bolt every year. So I liked the idea of, applying under Team Bolt and calling it Zap. I wanted something short and punchy, realistically. I think Farouk's intros especially work better when a robot's name is short and punchy. So by the time you're like short and punchy and electrically themed, like Zap is kind of the perfect middle ground for all of that. Obviously, it doesn't really go with the naming convention that I use for most of my combat robots that I build for this channel, but like I said, there's a slight naming convention to the BattleBots applications. Slight. It exists. But it isn't, the be-all and end-all either. Obviously, because I designed MacGuffin, but obviously didn't actually get in with MacGuffin, but that's fine. These things happen, especially when you're an international team going to BattleBots. Cool, so that gives us our first kind of wedgelet. We should actually cut that off at ground level though, just so that it sits flush with where the robot sits. Cool, so that's that one. And then what we want next is we wanted, some like actual wedges that come to a kind of point at the front, which is going to be interesting. I don't really know how I get a leading edge that is kind of angled like this, because if it came across flat, then it would touch the ground all along that flat point, but touching the ground at an angle is interesting. Maybe there's an extra like wedge piece there. Actually, that's probably what we'll do. I think we'll cut that at the angle and then we'll 45 it down so that it touches the ground along those 2 points at the same time. So obviously not related to some shitty middleweight from Classic Robot Wars. No. So here's the thing with me. My combat robot knowledge is very modern, in terms of like Robot Wars and BattleBots and all of that kind of stuff. I saw a handful of episodes, probably like 6 total episodes of the classic Robot Wars series as a kid, because that was all that came through on Australian TV and all I could get my hands on at the time. So anything that wasn't in those 6 episodes, and even then I only saw them once, aired on TV, so you couldn't even watch it back again if you wanted to. So my memory of all of that is hazy. So I'm much better on current BattleBots and the reboot of Robot Wars until it got canned than I am on anything in the classic era. Which is why there's a couple of people who I know that do podcasts and things based on knowing all sorts of robots that I haven't been on any of those, because I don't feel my knowledge is good enough for that type of thing. It kind of, if that makes sense. All right, so what we're going to do next is we are going to apply the outer edge here. Now, do I want to go... Yeah, so this looks like this section is about as thick as our angle is, which is interesting, because that's like a 40-something mil, 33 mil. Okay, we can do that. In actual fact, what we're going to do is we're going to copy... Yeah, we are. We're going to copy that. This is going to make our lives very interesting, but I think it's going to be worth it in the end. Now, which angle is that one? I think that's about straight. Kind of copied at a weird, or snapped at a weird angle there. I think because it was rotated at an odd angle. 7 is not enough. Let's go 7.5. Beautiful. Okay. Oh, and then we need to move this across as well. So we might even poke it out just a little bit and have it act kind of as pseudo wheel guards. I was not thinking a saw, bit hard to explain in text form. We need to draw it, but thanks for the response. Okay. Yeah, I don't really know what you mean by a reverse spinning disc, because if you've got the disc horizontally, then forwards and like clockwise or anti-clockwise makes no difference. If you've got the disc spinning up or like spinning vertically, then if you like normal would be spinning up and reverse would be spinning down like huge does. The only problem with spinning down is that you're fighting physics at that point. When you spin up, the energy in the hit, so because of Newton's laws, as you hit up and impart force that way, there is an force imparted into your robot, which kind of slams it into the ground, but your robot hits the ground, it can't go anywhere. So all of the force gets transferred through. Whereas when you spin down, what happens is their robot gets pushed into the ground and your robot jumps, which isn't great unless you're something like Huge, which is specifically designed to tank a whole lot of damage on the wheels and just be totally fine. That might be the thing that's happening. When is the next ARC event coming? I'm not 100% sure. I am hearing like some vague stuff at the moment about potentially the end of the month. The end of next month. So the end of April. But I don't know yet. That's not fully confirmed at this point. Right, so I've got this panel in, and we're now going to do the same trick we did last time. Whoops, that's not what I wanted to do. I wanted to put that directly on this corner and rotate it out so that we've got ourselves a wedgelet. Or a wedge, I guess. This isn't really a wedgelet. Okay, what does this shape actually look like? How does this work? Okay, so there's a weird angle across here where there's a cut. Can I work it out a little bit better from this side? Okay, so that's angled in and down. Right, that makes some level of sense. So not only do we have to angle this way, but we also have to angle the other way. So if we go to there, again, do our angling trick. It's a little bit sad that 123D design like stopped being a thing, but at the same time, they did get in some really good features before they actually like gave up entirely. Like this smart rotate feature was not a thing in the original version of 123D design, but it is so useful. I'm really not getting good shapes out of this tonight. Do I like that? I think this needs to be more like a triangle point almost. At least how many channels should a receiver have to have an active spinning weapon? 3. You need 1 each for drive, so 1 for left and 1 for right, and then the third for the spinning weapon itself. And you need 3 ESCs, 1 for each of the motors it's using. So 1 for left drive, 1 for right drive, and 1 for the weapon itself. Which 3 channels isn't all that common. Normally you'll get like 4 channel receivers as the lowest end of the number of channels. Look, you can do only 1, but that's if you're having separate receivers for your drive and for your weapon, which is definitely a thing that like BattleBots do, but for an Antweight, you wouldn't bother. You just put everything all in one 3-channel receiver. The only thing I will say about this too is be careful buying from AliExpress, because some of the controllers and stuff on there, especially the super cheap ones that aren't like full proper RC car radio gear, they'll say for channel, but what they mean by that is forwards for left, backwards for left, forwards for right, backwards for right. That's not proper 4 channel. A proper 4 channel has like the signals to do forwards and backwards on 4 motors at a time. I was looking to the cheap receiver. Yes, yeah. So it's some combination of letters and numbers, but yes, that receiver is still one that I use to this day. The other thing that I use, which I actually might have one on the desk in front of me, do I? No, I don't. I moved them. But I also use Malinky Nanos because Malinky Nanos come with 3 brushed motor controllers built right into the receiver, which is exceptionally handy. Yeah, I really like the Malinky Nanos. A lot of my current builds are running them, so yeah, that's where there's one. There's one in Mini Mammoth at the moment, which I still need to make weight with yet. That's still a little bit up in the air. Okay. This is the bit of the CAD process that is interesting at any given time is looking at something and just being like, you know what, I kind of hate this. So what did I want to do with this? I kind of wanted a triangle, but like a half pyramid. I think if we like do that, and then do this, and then cut this pyramid in half, this might be our start point for the next section of this. Because I think this gives us a better outline than the angled wedge that I was going for there. It's actually going to, I think, do us quite well once we get it in position. And of course resize it, because it needs to be much different. 63, that's quite long. I mean, we don't need to worry about like a cube rule or anything, but it's still a good idea to keep things reasonably sized. All right, now let's take a look at that. Okay, so that's interesting. I kind of like that, but I now want to try and get this like other angle that was going on. I almost need to like move this piece over all the way through and somehow manage to make a like join line at a 45 type thing down through here. That's going to be tricky, I think. I think the other thing too is we've gone a little bit away from the original design intention, because almost like this section here should really be flat. Like I kind of want a flat point on this side rather than a triangle on this side. Is there some bot in lower weight classes you would like to see in heavyweight classes? Oh, in heavyweight itself, personally, I'd like to see Rumham XXX. Yeah, Rumham is scary. There is a featherweight version of Rumham, which is also particularly scary. The only thing I think if you scaled Rumham to a heavyweight, you end up losing a bit of the Rumham-ness, if that makes sense. Just because Rumham, part of its design is that the weapon is a hub motor, and heavyweight hub motors, people have tried, I'm sure, but they're very, very difficult to pull off. So not a whole lot of people actually do use them, which I guess is a bit of a shame, really. All right, so I wanted a cut line through there. Now, probably need to merge that somehow as well. All right, I think we're going to do something I don't normally do, but we're going to try and like draw a cut line in. See what we can do with that. Now, split that by that line. Remove that. Okay, and then what we want to do is we want to split this here as well. Split tool gone. There it is. Body to split. Splitting entity. This guy. Cut and delete. Cool. And then we just need to get these two pieces to merge. Which I think... actually, I'm going to try a merge tool here. We go on loft between there and there. Nope, that didn't work. Let's try cutting this guy down. Whoa. Oh, I didn't answer the question too. What would I like to see at a higher weight class? Well, I mean, I guess my melty brain, really. Like, getting Zap into BattleBots would be exceptional. I would, like... And I guess part of me doesn't even really care if it's me that gets Zap in, but like seeing a dual spinner melty brain or a melty brain at all in BattleBots would be amazing. I really, really want somebody to get a melty brain into BattleBots. I think we need it at this point. The melty brain tech is crazier than it ever was before, and melty brains themselves are just way better than they've been in the past. Like, I think, yeah, comparing melty brains of today with the melty brains that BattleBots is probably comparing them to, because I know that there was melty brains in the old stuff. Again, not really an old BattleBots person, but I do know that there have been melty brains then. And from kind of like what I've heard, a lot of the current rule set is based on the fact that yeah, things didn't go particularly well in the old series, and they want to try and keep fights from going that kind of stale way that like Wedge versus Wedge or two melty brains versus each other that can't move at each other across the arena, so it's just a 3-minute fight of sitting and spinning in place. Which, you know what, I get that. They're making a TV show, they want it to be exciting, they want it to be interesting. Yeah, they've got to do things that they, you know, whatever they can to get that to work. That's not what I wanted. That angle is right, but this corner is all shades of messed up. I think, actually, that's because I actually want that plane down to the, okay. Yeah. That's what I want. I want that shape all the way down to there. So we're going to just try cutting that and seeing what happens. Don't know if this is going to work, but we're going to give it a try. This is a very experimental shape for me. Of course that's not going to work. Okay. Alright, how do I do what I want this to do? I think we add just another layer of like cladding over this essentially. So what's our height up here? 32.74. Alright, let's layer a thing down. 32, well, we'll just make it 33. That's fine. Width 2, height 20. Okay, this might be the go. Maybe, we'll see. Push this out. I think we're going to lose some of this like flat section here because we're kind of going out off at an angle somewhere. I can't actually, yeah, this This design is a design for a helmet, so it's not at the right angle to be looking at all of the shapes and things that I need to be looking at right now to work out how to do this. I don't know. I don't know if I like that, to be honest. Okay, what we're gonna do, try that snap again, but this time we're gonna push it into the piece and see what happens. So try and get the angle right. Okay, that looks better lined up. Wow, we're all kinds of funky angles at the moment. If you have any suggestions or have any thoughts on where this design should go, I am kind of just flying by the seat of my pants here, so I am more than happy to take on suggestions and ideas at this point. That is an interesting shape. I think we can work with that. Would kind of mean killing off this section back in here, but I think we can do that. It's not a huge deal. Actually, let's do the same thing we've done before and cut this along the bottom edge so that it actually looks like it's supposed to look. Split along the ground plane. Okay, and then let's also just for fun split it along the edge of the actual robot. Okay, this is coming out very differently than I expected it to, but I am actually not unhappy with this design at the moment. I think the only problem I have with it is that the actual edge touching, the ramp that we have here is nothing, because this front point is going to be the bit that touches the ground. That's it. That's all that we're going to get touching the ground. So as a push bot, it's not going to be super, super effective. Maybe make some hexagons, create some similar shaped gaps. And remove the middle section. Oh, so you're saying like cut a hexagon out of here type thing, out of this middle section? Is that what you're thinking? We kind of do have a bit of a hexagonal shape going on, actually, which I don't mind at all. Because once we mirror this too, like we'll mirror this in a second, and we'll get some interesting things happening. Also, I should split this by that so that when it gets mirrored, it's mirrored correctly and everything works out. Okay. In fact, let's just give that a quick mirror right now, because mirroring it will actually give us a bit of an indication as to what things will look like in the final design. Hey, you know, I don't mind that at all. It's big and scoopy and interesting. I think the only problem, as I said, is going to be having this scoop actually do anything, because it's only really touching the ground on the front points. Unless, of course, we change where the wheels sit, raise the wheels up, because at the moment, if we put these wheels in where they're supposed to go, which we can do really quickly. Oh, kind of really quickly. I forgot that these... look, this will be fine. It's not perfect, but it will do the job. Yeah, so that's where the wheel's supposed to go. And you can see it's actually 5 mil or so down, which means the whole thing gonna sit at an angle and scoop. Which is not like it's fine, like that works, and you know it'll work for everybody, but like it will work as a robot. But again, it's just going to touch the ground only on really like 1 or 2 points. Hmm. Yeah, I look, I don't mind this at all actually as a design currently. I think we need to clean up the underside a little bit because we've got some weird and interesting shapes going on here, like these little points that stick out of the place. But I think we can do that fairly easily. Okay, how's it going to be the easiest way to do that without destroying everything? Oh, I know, we're going to cut based on this plane. Whoops. That's not what I wanted to do. Lots and lots of shape cuts in this, as you can see. This is kind of how I do design in this program, just because it's easy, really. Cool, so that's a shape cut there, and then we can shape cut this triangle and knock the point of the triangle off, and that should actually work quite nicely. I was thinking maybe a hexagonal scoop externally, and then mount it on afterwards. That's not a bad idea. Yeah. I can see what you mean there. Have like bolts or something in the back section here, or even just points to glue it all together. And then, oh yeah, because that would mean that you could like ride the whole thing along the ground. Because that's how I run Spooky. Spooky is printed in 2 parts and glued together, so the whole flat section runs along the ground properly. That definitely works. That's a strategy that we could definitely use. So I'm just going to quickly do that because I'm going to... Nope, not what I wanted to do. I wanted to cut this by that. Then we get rid of that. Don't like this hole in here, but we'll fix that in half a second, I think. Also, I might just, before we go any further, copy and paste this whole mess so that when I start messing around with things, I've got a copy that I can backtrack to if I need to. Because once I start joining parts together, it becomes a bit of an irreversible process here. So if we merge all of these, that's now become one solid, like, wedgelet shape, essentially. And then maybe we can sort out something in underneath here. It's probably going to make weird shapes. It is indeed. That's fine. We'll just cut that off where we need to, as we've been doing all of this time, because of course, split that, bam, bam, bam. Now we've got a flat bum under there. Perfect. Yeah, the print in place and glue sections is the next thing we need to do. And what we're actually going to need to do realistically is work out where our ground point is. So there's a really, really easy way to do that, and that's literally just to make a ground plane by putting a box on the wheel, rotating it until it's underneath the wheel. 90 degrees, there we go. And then expanding that. Boom. There we go. So how far off the ground are we? That's the question here. Between there and there is 3 millimeters. Okay, that's not too bad. Because that means we can literally just like 1, 2, 3. Whoop, 3. So that is it sitting on the ground. That is a lot of contact point, but that should be okay, I think. Like, we're running N20 motors. These things have enough power to push through this, no worries. So let's mirror this out then. Choose all of that, mirror that out, just like that. Cool. So now we've got our scoop going on. And yeah, I guess all we need to do then is sort out some way to mount all of this up. Which is basically just going to mean finding a point in here that works. So what we're going to do is we're going to merge all of this stuff together. I could have it slot together, actually. That might be an interesting way of going. because it kind of already, like, it's going to lock together a little bit anyway, because all of these panels kind of have to sit where they're sitting almost. Like, this angle has to line up and stuff, so that could work. And then we could just slot it in place with a little, like, dovetail joint almost, but not a proper dovetail joint because I can't be bothered doing that much work on this. All right, what we're going to do is we're going to move our scoop wedge out of the way for the moment. We're going to build a little system into here that does what we want it to do. So 10 by 10, that should do us. Snap that up. Push that into here. Back it out this side. Okay, then ground it down. Here's what we want. Is it on the bottom so that it prints in? So what I'm thinking is we're just going to cut this off at an angle. I might need to copy and paste that. Just put that out somewhere for later. Push this down. What I need is that guy. Okay. 4 mil up and add 4 mil to the bottom of that, just like so. Cool. So this is going to be our little locking lug, essentially. It's going to force the other piece, which we're going to make in half a second just by removing. Actually, we'll make it now. It's going to be easy to make it now. Just like that. And then go subtract that from... Whoop. Come on. Oh, actually, I know what we can do. Make this easier on myself. Go subtract that and that. Bam. So that's our little locking lug. So this will get attached into the back of the wedge. And then between this geometry here and the geometry of the wall, everything should just like click together. We might throw some external edges on this as well. So we're going to do... no, I want... Whoa, that's not what I want at all. I want 2 mil wide by 10 mil by 20. That'll do. Snap that onto there. Make sure we ground it out properly. Boom. What? Why? This program doesn't like the snap tool all that often. Like sometimes the snap tool just goes wrong. Like that should have snapped everything together nicely and it did not. And then we're going to mirror that across so that we've got our edges for our snap. Sweet. And then we're going to merge all this together and then force it into there, and then lock all that together. So that is all together. We're going to merge this and that. Bam, done. Should be. Cool, so that's our little locking lug. Actually, the only thing that needs to happen now is we need to add the little bit of play that you need for 3D printing. So 0.3. Done, done, done. Oh, I see. That and that are not connected. By how much? Drats. Okay, that's fine. We'll just do that, and that will work. Think you need a couple more locking points. So this here is going to lock into that, and then if you look at the shape of this wedge, like this back section here, like sits flat against this front here and this front here. So there's two like angled shapes back here that are going to sit and lock in place there. And then this top edge of this wedge also locks down on the angled shape of the front. So it should all just like puzzle piece together. And how's it going, Chris? Don't forget to resize the other lug. Yes, that does need to happen as well. But what we need to do now is get that into its right spot. That should be okay. I might actually do a print of this as is and see what we can do, see if it actually prints correctly. Actually, I've just had a thought. I think that angle is going to be impossible because if we move this over to the wedge, yeah, so first of all, it's going to stick out into the wedge, which is a bit of a pain. I mean, we can cut that off and we can mess around with the design and stuff and it would work. But the other thing is we've now got a nice sharp point down here that is an overhang for the 3D printer to print, which, yeah, 3D printers aren't particularly happy with an overhang like that. So I might need to flatten off our locking lug instead, rather than have a wedge shape. And this is why I should have copied everything rather than having to, like, undo spam to get back to where I am. Yeah, so we need it because, yeah, this way we'll have a flat bottom on the piece that is an overhang, which will mean that it will actually print flat, which will be a little bit better. Yeah. It's one of those things that you can make really, really cool looking designs, and then you go to print them and you're like, oh, everything is wrong for 3D printing. Whoops. This should have been very different, which unfortunately is just a thing that happens from time to time. It's one of those things that I'm still not really good at is designing for printing. Because it's something that I don't always consider right when I need to. So I need to redesign this locking lug then so that it locks forwards and backwards and locks at the right height and is nice for the 3D printer. So I think the other thing I'm going to do is I'm going to add a little bit of an angle in the back here, chamfer up these, because right now all of these back little triangle wing sections are going to touch the ground, which that's a lot of surface touching the ground that just doesn't need to. What? They did different things. That's just weird. Okay, I can do 5 on there. Can I do 5 on the other side? Yes. Oh, I can do more than 5 on the other side. That's crazy that they can do different amounts of chamfer. Anyway, the only building I do is models built over half scale. R2-D2, T800, and now building Ghostbusters Echo 1. Oh, nice. All of those are very, very cool. I want to do an R2-D2 at some point. Mostly because I know some of the R2-D2 builders around the place, and they're really great people. Also, the Dalek builders are really great people too. I would love to build a Dalek, but I don't have the time or space or funds for that. Especially with all of my funds going into combat robot stuff at this point in time. Kind of want to get rid of these little back sections as well. They're not really doing anything. Guess as long as they don't collide with the shell, they should be fine. Oh yeah, they've got plenty of space in underneath the shell. That's fine. All right, back to these locking lugs and how on earth we get them to work and also 3D print properly. I think it's kind of inevitable that we just have to have something flat somewhere along the line. I guess the other option is to do like prongs off the front here, which stick in a different way. So like rather than that guy there, we do a couple of these and we do like one here, one there. Where do they line up on the actual wedge? Because it'd be nice if they lined up somewhere that we've got a bit of space. Okay. Oh, actually, that's a good point. We can just put them into these side edges. Come on. I want you back over here. Somewhere. Over there. And if we build our little locking lugs in here, 24 across and 24 across. So what am I doing? I'll just mirror these once I'm done anyway. This should be... Well, that's not what I wanted to do at all. Just move this out. Should be baseline level, I think. All I need to do is chamfer this top section. Like so. And then I can cut this shape out of the wedge, and then it would just like bolt together or like glue together using these two wedges as locking lugs. That should be, I hope, all I need to do here. And these shapes are well suited for 3D printing because they are flat where they need to be flat and angled at the top, which will be fine for 3D printing. You'll be able to print it without support. Although I don't know if this part is actually going to come off the printer without support, to be honest. Okay, so we're a little bit too wide. But that's okay. We can deal with that. We can just change the geometries. 5 mil, like that. And then we're going to push the locking lug in by 3 mil, I reckon. That'll do it. Cool, so that should be the locking lugs done, which all that means now is we need to move this over here. Create a couple of copies, move those over as well, and do the subtraction. All right, subtract. There we go. That one, and that one. Bam. So there we go. That's our two little locking lugs. They should be relatively secure. And again, there is going to be this this point of contact between the two planes. So that should be okay. I think the only other thing that we could possibly do is fill this back section. It is looking a little bit odd at the moment. I do want to see what happens if I try and get rid of these little pontoon bits that just kind of... yep. Nope. That's... It's not really what I wanted those to do. I could definitely cut those fingers off, I think. Although those kind of fingers, cutting them off can sometimes lead to more trouble, as we saw earlier with this type of stuff. All right, let's try and cut those fingers. Oh, of course, I don't want to cut it there. I want to cut it at the ground plane, because that's sitting on the ground plane, not on the plane at the bottom of the robot. Hey, there we go. Look at that. Okay, that actually worked out quite nicely. All right, what are our thoughts? What do we think about the side panels? Like this, I kind of like the look of this actually. Even though it's not what I was going for and it's a little bit janky, I'm actually not unhappy with it. Could maybe do with trimming up this area. Actually, let's see what happens if we try that. Let's just grab this. Ah, that's interesting. It's not what I expected at all. Let's try and get that to a center point. Let's do 55 and see what happens. Because then we're going to do the other side and see what this does. You know I like that. Ah. Oh, although we've got a little straggler at the back here, which is going to mean that it's not going to connect to the chassis correctly. Ah, don't do that. Maybe it will. Let's see. Try and move it over. Ah, by doing that, I've changed everything. Cool, 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 cool. That's what I wanted to see. I really do like the look of it. Actually, it's giving me a little bit of tough as nails vibes, despite the fact that it can't open and close. It's just like the shape more than anything else. Okay, we need to back out then and do that, because we need to keep those top edges kind of the same, but we might be able to like see if we can do this and just give them a little bit of a nudge. And maybe chamfer them together. Yeah, there you go. It's been like itching at the back of my mind going, what does this remind me of? What is the robot that I'm thinking that this is? And yeah, no, it's tough as nails. That's the thing that I think that this is. Or I guess hold my beer too, really. That's the other robot that it reminds me of, because those robots are very, very similar. Oh yeah, here we go. That's a bit better. I like that a bit more. And I think the thing with the like tough as nails aesthetic, or like the hold my beer aesthetic, is that if we try and fill in these side sections, we're gonna lose some of that aesthetic that we've been going for, or we've just like happened upon. I definitely have not been going for a tough as nails aesthetic. It's just kind of happened. I do want to know though, if I like chamfer out here, is this just gonna wreck everything? It's not gonna wreck everything, but going too high with it does make life look weird. 7 mil is not bad. I kind of like not having that angle in there. I think, yeah, having just like this nice thick side pod on it is a good idea. Okay, so 7 mil chamfer on the other side as well. So just got to kind of copy everything we're doing, because, yeah, I should have really left this as, actually, I do wonder if I do 7.5 instead. All right, 7.6. Nope, not 76, 7.6. Okay, 7.55. 7.56. At some point, this is going to explode. There it is, 7.57. Right, 7.57. So let's just go back and do both of them exactly the same. I kind of want a symmetrical robot. 7.57. There we go. That just gets it as close as we can get it to being perfect in under here, which it's never going to be because it's just a mash of different bits and pieces. But, you know, that's fine. These things happen. 7.57. Bam, bam, bam. Cool. I am really liking this, especially as, yeah, it's not exactly what we were going for from our little sketch here, but I think it works pretty well. And even though it's not exactly the same, it does still give me a little bit of like samurai helmet vibes, which is kind of the other thing that it was supposed to be realistically, is yeah, samurai helmet vibes just like this, which is quite cool. We've got a hole down there now. I don't know where that's come from. Oh well, that should be fine. And yeah, I'm thinking that this should be, yeah, it's going to be a 2-part print and then just get glued together. And you just do that once and never again. You could almost even do this the same way that I've done Crudity model here on, well, no, Crudity model is the featherweight. This is mini model. And do a flexible piece. So print this whole front section flexi and then glue it to like an ABS or a PLA chassis. Probably a PLA chassis, I would say, for this particular design. Because, I mean, it's going to be light anyway, so there's no point really printing it in ABS because it's just a lighter plastic. And also ABS is harder to print a lot of the time too, so... I think the only thing that I'm now worried about is these wheels are not going to touch the ground. Like, if I just mirror this wheel and this motor across... when we have a look at this, you'll see that the wheel is like all the way in here and the back is like all the way out here. So that's not going to touch. So we almost need like a bump or something out the back here just to give us a little bit of extra protection, I guess. Well, it's not protection. It's more just like not getting stuck up on your back and doing the... Was it overdrive? No, overdrive got stuck on its weapon. It did the thing. But that's the kind of idea that I'm going for. It needs some way to not be stuck on its back and just like be able to roll back over again. Which, given that the way the wedges and stuff sit, I think if it lands up on its back, it's probably going to roll back down the right way because the wedge is going to be a force going in that particular direction. So the question is, how much of an angle do we put on this back plate? Let's take a look at this. It is 28 mil. We're just going to do... So my typical trick for this is I'm going to grab 2 boxes. This is the way I do this is a little bit long and convoluted, especially for the end product I end up getting, but that's fine. We do this. We do this, we subtract or we split this in half. Kind of doing this semi-tutorial as if this is going to be helpful for anybody other than me, because like this program is not really all that available anymore. What? Why? That was weird. I was saying rotate and it was not rotating. Very, very odd. Okay, let's hide that. And then we're going to align this with the bottom of the wall, as we've been doing before with the align tool. Perfect. Now, the next thing is going to be to smart scale this thing. So it's at 28.2. We want that at 28. Oh, that's interesting. 123D design has crashed. I didn't save that. Oh, where's our... How far through are we? Okay, we've got most things. Streams and old software that I probably shouldn't be using anymore, but is just useful. Like, trying to bash out an ant weight this quickly in Fusion 360 just wouldn't happen. I can't build something this fast in Fusion 360. I guess mostly because of stuff like, you know, half of this chassis was just a chassis I already had ready to go. So that does help cut down the time quite a lot. I kind of underestimated how much time Mini Mammoth was going to take for me to design, mostly because I was like, oh, well, surely I can just design this really quickly, because I've designed ants really quickly in the past. But of course, I did everything in Mini Mammoth from scratch because there was no baseline chassis that I could borrow to nab parts from. All right, we are back to basically where we were, and we're all saved. So if it crashes out again, we should be okay. I should take a quick drink and keep going. So now we're going to actually do the thing that I wanted to do, which this should be 28. I think that's taken it off top and bottom at the same time. So we need to do the alignment trick again. Line to the bottom. So I could actually just leave it as a just a single wedge, but I might push it all the way out to the sides of this as well. I'm going to do our smart scale, and we're just going to turn this into let's see, I think a 2 mil bump or something. That's a 3 mil bump. That's going to be enough, I think. We could probably go 2. Yeah, 2 mil will be fine. It doesn't need to be heaps. It just needs to be enough to, yeah, let it actually roll back over. Yeah, you always should save your work as you go, but I sometimes get complacent with that and don't, and that is always to my detriment because this program crashes a lot. So, do you just want to see if I can here we go. Now I've got those tabs to appear a bit more. All right, so let's see, how much did I push pull by? 2 mil. Okay, so when I finish doing this, we're going to put the tabs back up by 2 mil. I'll put the base back up by 2 mil. Now let's see if I can get rid of those. Now I can get rid of the tabs. Okay. Now we're cooking with gas. So what we want to do is snap that to there and then move it over to the tab so that it's right on the back edge. Oh, cool. I'm so glad I managed to get rid of those. Those were going to annoy me no end if we managed, if we got to the point of trying to print this thing without those. Sorry, with those in there. All right, so how much more do we need between here and there? 12.556. That's just an annoying number. Let's see if the copy to clipboard is going to work for me today. It did. Look at that. Now this should be the same, theoretically. Yeah, nice. Okay. We're just going to save here, and then I'm going to merge these two together. So that gives us our nice back panel, and then I might also even just give a nice little, let's see if we can do a chamfer on here. I don't know if it's going to like this or not. No, it's not going to like it. It does a little bit. Bit of an interesting chamfer. Oh, actually, we can chamfer the other way. That's a good point. We can maybe do this way. See if it likes this. Nope, doesn't really like either of those things. But I don't mind that. And that keeps our design intent, which is to stop the robot from sitting on its back. .3D printing that might be a bit of a pain, but it should be okay. Can you delete faces with 123D like you can in Fusion 360? You found it handy to blend two different geometries that would be hard to do manually. Not particularly. You can select faces, but the face tools in this are buggy at best, I would say. They're not powerful or useful in a lot of ways. To the point that it has a full sketching system in it. There's a full sketching system here where you can create a sketch plane and create squares and then, add circles and stuff to your squares, and then you can do your classic thing of extruding just the bits that you want, but Fusion, 123D has a tendency to crash when you leave sketches in your designs, especially if you do multiple sketches. Like, if you worked in 123D the same way you work in Fusion 360, doing lots of sketches and extruding lots of bits and pieces here, there, and everywhere, it would crash in like 30 seconds. It's just not really built for it. No, so this software is not Fusion 360. This is 123D Design. So this is a design software put out by Autodesk, the makers of Fusion 360, but this was put out by them in the 2010s somewhere, and they had it as it's a free, or was a free software on their website, and had a whole bunch of stuff. Like there's a save to cloud option, which is all broken now because all of their cloud storage and stuff is disabled. But it was a free option, and then they decided to abandon it when they started like pushing Fusion 360 really heavily. This software, actually, by the way, is why I don't trust Fusion 360 all that much, because Autodesk are already into a habit of saying, oh, look, here is a cool free CAD software that you can use, but we're going to take this away now. And at least with 123D Design, it's an offline program. I save all my files offline. I can still access everything, even though Autodesk have shut down all of their servers. Fusion 360, if Autodesk shuts down all of their servers, then it's like good night to basically everything you've got saved in Fusion 360, unless you manually go through and save them all out like on your own before they do that, which is just, that's going to be a lot of effort for a lot of people when they do that. Is it a performance issue or just instability? A little bit of both. It doesn't really like Windows 10. It was definitely designed for like Windows XP through Windows 8. Windows 8, I think. And it hasn't, like, they abandoned it as people started pushing towards Windows 10. So I think it's just a case of, they gave up like releasing updates and stuff for it. So it is a little bit unstable at this point in time, especially like when I finish the stream tonight and go to close this, it will crash the program. Trying to close the program out crashes the program for no apparent reason. It's just one of the quirks of using this particular piece of software. Cool. So I think we're really close to being done here. The final thing I want to do is cat up a lid to sit on top of here. I think I've got a lid that should work with this design catted somewhere else, because I don't think we really mess with the geometry. Oh no, we did. We changed where the back wall position was, because that was the front wall in the original design. So yeah, we need to redo the lid for this thing. So what we're actually going to do is we're going to cheat, because cheating is good in some respects. Actually, we're not going to take that one, because this is one of the ones that's got the dodgy little feet on it. You mean it make sure it closes? Yeah. I mean, it's a case of like you close it out with the little like X, and then it hangs for a second, and then you have to do the like Windows force close thing to get it to like actually close, which is hilarious in a sense. Okay, we are going to use this one because I'm feeling lazy, so we're just going to do this and fix this one up as well. Whoa, okay. That was interesting. It's one of those things, again, about using 123D Design, is that sometimes when you do something, you get results you did not expect. So we're going to subtract stuff again. Bam, bam, bam. Flick this back up by 2. Okay. Whoa. Yep. Oh, 123D Design, you do weird things. Flick that back up by 2. Yeah, the hanging possibly is. The one thing I haven't done yet, which I do need to do, is try running it on like a prosperity mode. Like you can get Windows to do the thing where it's like, hey, run this as if you're Windows 8 instead of Windows 10. I haven't tried running it like that yet. I really should. That's probably my next trick with trying to get this all to work properly. So what I'm doing now is I'm making the lid in the cheatiest way possible by literally stealing the whole robot, slicing the base off, and using the base as the lid, because that's exactly what it is in this particular instance. There's no real difference between this design and the lid. So there we go, that's a lid in place. The only thing that we need to do now is, this is probably too thick, it's probably like 2 mil, and the lid doesn't ever need to be 2 mil thick. You know, obviously, seeing as I've run robots with like 0.5 millimeter plastic out of a blister pack on them as a lid before. But to be 3D printable, it should have some thickness to it. So we're going to add a little bit of thickness back in, and then we're going to throw our motor mounts down and use those to make the standoffs between where the motor mounts are and where the lid is. Because if we do this, you can see that the motor mount isn't going to touch the lid at this point, and we want it to. I guess the other option here would be to pull the lid in a little bit and have the lid sit down inside the robot. Like we could do... Oh yeah, it's 2 mil. So yeah, if we did this instead, hang on, we just like grab all of these walls, push them in by 2 millimeters. Well, 2.3, so it's got enough space in the 3D print to actually work. You could then just drop the whole lid down by 2 mil, and that would... Oh, this front wall is thicker than 2 mil. That's interesting. There you go. I don't normally do that, but I guess it... Well, actually, it was supposed to be the back wall. It's very odd. We go an extra mil. Oh, but before we do that, we need to change the bolt hole size. Bring these in, because these really only need to be big enough to hold a screw, which is like, yeah, that'll do them. Go in by 1. Beautiful, there we go. Actually, that's quite nice. That sits down really well. So there we go. We've got the scoop, got the body done, got the... Oh, we need a switch point. We need to actually be able to turn the robot on and off. That's a good idea. Oh, we should also put in some pillars out the back to mount the switch to. It's not a bad plan. So let's get rid of our lid for the moment. Yoink. 150. Where's that? There we go. I'm going to try and mount a switch off of this back wall, which usually all I do for this is just like leave a good gap. And then we're going to... I'm just going to, this time round, because I'm actually thinking as this is going to be a lone bot, I kind of want to design this so that it can be up on like Thingiverse or Prusa printers, and other people can print it out. Okay. So those two little posts at the back there are literally just to kind of like give you a point to glue the switch into. They're probably not exactly the right size, but everybody's going to use different switches for this. So it's kind of pointless to go through and like size them exactly for a specific switch, because yeah, I just don't know what switches are going to go into this thing. So then we're going to merge those posts in. Might even just push them down just a touch. How much gap have we got between here and there? 8 mil. Let's go down a little further. Another 2 mil. That'll give us 10 between here and the top plate. Which should do fine. And then the other thing we're going to do is we're going to cut a hole for that switch in the lid. Yeah, we'll do 10. 10? Oh, 10 might be a lot. Oh well, we'll find out literally the easiest way we can by just subtracting out. You know, I don't mind that. We might also, just for the sake of it, chamfer these corners. Yeah, okay. I really don't mind that at all. Then we put this back over here. 150, exactly where it's supposed to be. Ah, I am using the wrong motor mounts for this one. This has got the DF robot. This is a DF robot motor mount, and this has got non-DF robot motor mounts, which is why the, sorry. This is this motor bracket and then the motor mount. So DF robotics motor bracket and non-DF robotics motor mount. And you can see that they're different widths. That's because the DF robot ones are designed so that they sit the DF robot so that it's got the ESC that's pointed into the robot, whereas the old style, whoops, this old style that's on the bottom here is actually for having them this way, which is of course no good for the DF robot motors, because that way, well, actually I can literally just show you, it will poke the ESC out of the top of the robot. Just like that, which is annoying. Hi Mark, how's it going? Yeah, so I need to think about this, because I do like this design as it is, but it might be useful to have this compatible with DF Robot motor mounts. Or, well, just with the DF Robot N20s. Because they are a nice, easy way to get into the sport. I mean, then again, the other thing that's happening, though, is that there's Malinkis and other things going on right now, too. So you could easily run this off of Malinki, no problem. Which, you know, I almost recommend, especially if you're getting into the sport for the first time, because being able to, yeah, just buy one electronic component which will run your drive fully is amazing. All right, I think we're actually getting towards the crux of this. I think there's not too much more to do, unless anybody can think of anything that I need to add extra into this design. I think we're actually getting pretty close now. We're designing a lone ant weight. So this is going to be a robot that I don't drive, but somebody else drives. So like, we at ARC always run loan bots where people can walk in, pay an additional fee, like registration and a little bit more, and then drive one of the robots that like club members have designed and built and, you know, maintain for them. So this is one of mine. I'm also going to like build up a couple of my old chassis. Like, this is a flexible TPU chassis, so a kid driving this is going to do no damage to it at all. But I wanted to build something new and try something else out and see what we could get going on stream today. So what we've come up with is this little, like, kind of samurai-esque, tough as nails-esque wedge bot with a detachable wedge. So the wedge is printed separately, and glued onto these two little pegs. Oh, I need to merge those pegs in. Just like that. So now we've got those pegs merged into the chassis. So yeah, you can see out the back here, it merges in with these little, like glues on with those little pegs, which means you can print it in two parts and in two colors and just run with it, which should be good. It also means that this entire wedge scrapes along the ground when you've got 40mm wheels in place. Needs more fillets. We've got a fair amount of filleting going on in this robot so far. Like all of the underside areas in under here have all been filleted so that they don't touch the ground as much when it's driving along. Actually, I was going to fillet in under this edge as well, because again, this part back here, like, it doesn't need to be huge. That should be fine, I think. And the more we fillet this big section under here, the less is actually touching the ground, which is good because it means the less drag on the robot driving around. Because the other thing I want to try and do at some point is I've got these, I don't know what they are. Oh, they're lithium-ion cells, which these only put out 3.7 volts, but they are like 500 milliamp hour. And for a two-wheel drive wedge lone bot, like those should be enough to drive an entire event no problem. So I want to try and run these, but yeah, the big problem with those is they're only 3.7 volts. So I'm going to need to run like N10 motors, 10-to-1 N20s in the robot so that I can run the whole electronic system on 3.7 volts and they still manage to keep up with everybody else in the arena. Because otherwise running on half voltage essentially is going to mean you're really, really slow around the arena. I think I also might... So we're going to print this, obviously. I'll probably do like a short video on it, like printing and building this at some point in the future. Probably won't be this week, probably be like a week or two from now. And if this goes well, and if people like it in terms of like using it at events and also downloading and printing it, I might even try another version of this that has a little flip arm in the middle, just run off of a like high voltage servo or something. Because that could be quite interesting as well, to be honest. Yeah, so torque is a problem, running like 10-to-1s and 3.7 volts. However, like as I've seen with my torque testing so far, at 150 gram scale, you don't have enough weight on the wheels to actually max out the torque. So realistically, the maximum torque you get out is determined by the grip that you get on the wheels, which again, because you don't have all that much weight, is fairly limited. So I think even on 10-to-1 at 3.7 volts, you're still going to be okay as long as you've got like the same wheels hitting the same wheels and pushing against each other. I don't think you're going to see that much difference in torque, to be perfectly honest. I think it's going to be, yeah, around about the same, actually. I mean, I should test that, really. I should put my money where my mouth is on that and test that. I do need to sit down and finish off the torque testing setup that I was working on. But of course, most of my design time and bits and pieces in recent memory have gone into doing Zap because, of course, designing a heavyweight is a crazy undertaking and there is lots and lots and lots of stuff to do. Maybe lose the punchy control? Yeah, I would not going to doubt that at all. But again, this is a robot designed to be loaned out to children, essentially. I mean, there might be other people who come in and loan robots out, but like the majority of people who loan robots are children. So it doesn't need to be like amazingly punchy and precisely controlled because the person driving it is going to be driving for the first time. So if it's a little bit slower and a little bit easier to control, it's probably actually better because at least they get it to go where they want it to go, unlike having 10-to-1s on 2S, which is just a madhouse. Even for somebody like me who has driven a fair amount, I still can't control 10-to-1s on 2S. That's a lot, realistically. All right. Well, I think that is probably going to be it for this video. This has come out really well. I'm quite happy with that. So I'm gonna say thank you all for being here and joining me on stream and helping me out a little bit as I've gone through and kind of worked my way up from some very weird looking things to something that I'm pretty happy with. I'm pretty proud of. Designing a heavyweight is a dumb thing to do. Yes, it is. It really is. Especially when at some point I need to do a video on the BattleBots application process because BattleBots ask so many questions about so many different things. So like the CAD that I've got at this point, this is good enough for me to sit down and build this ant weight. This is not enough for BattleBots. Like you need so much more in your CAD than something that looks like this to apply for BattleBots. So yeah. If these are wedging machines, maybe test it with added weight coming from another robot on top of the wedge. That will increase gear, meaning more load on the motors. Yes, yeah, no, I agree. I definitely think, yeah, putting something on the wedge to test it out is a good idea. Again, this, like, running them on these, like, lithium cells is just a theory at this point in time. I don't know how practical it is. The only thing I really, like, the reason I want to do this is because if you can do this, then it's, like, USB chargeable, which means that I can loan the robot out to somebody and then just say, look, between fights, undo these screws, unplug this thing, plug it into the USB charger, and away it goes. Like, you don't have to worry about, like, LiPo charging and LiPo safety and stuff, because the lithions are a little bit more stable, and again, you can just plug them into a USB charger and away they go. So, you know, it's a little bit more of like trying to be a little bit more hands-off. I guess the other thing too is I could just stuff a massive 2S lithium battery in this thing, like as big as I can possibly fit, charge it up once before the event, and just say, don't worry about charging it, it will be fine for the entire event. Trust me, it will be okay. Which is the other option here. And I mean, we could maybe put like a 500 milliamp 2S battery in these. Maybe. Might need to make the chassis just that little bit bigger to do that, I think. But should be possible in an ant weight for sure. Especially one that's just a wedge like this one is. So I'm going to save this again before 123D crashes on me for another time. But yeah, now I think it is actually going to be time to wrap this stream up. So again, thanks for you all for joining me on this fairly impromptu stream. I need to do like streams where I've like set up a time further in advance than this, so you all know when I'm going live and what I'm doing. Anyway, that is going to be it from me. I will see you all in the next video.